Good afternoon. I am Genevieve Babaan from Project GUHeat, and my presentation is entitled Understanding the Thermal Environment Condition of Quezon City. So first, let us define what is urban heat island. UHI is a phenomenon which results from having higher air or surface temperature in urban areas relative to the surrounding rural areas. So, UHI is measured by the surface temperature and air temperature. Surface temperature, ito po yung values ng temperature na makikita natin sa satellite-derived temperature maps wherein pinapakita niya kung ano yung temperature ng surface or ng ground. Also, we have infrared thermometers that can measure the temperature of different materials or surfaces. On the other hand, meron po tayong air temperature, which is ito yung data na nanggagaling sa ating weather stations from Pag-asa. And we also have mobile temperature sensors na nagme-measure din ng air temperature. Air temperature is being measured above the ground surface, wherein itong surface temperature po ay minimeasure niya yung mismong material, mismong surface. So, UHI at daytime and nighttime, we can see na ang urban heat island are where the temperature is higher in overdeveloped areas. Makikita natin na yung difference ng temperature sa urban areas as compared dito sa low values in rural regions. And in nighttime, sinasabi natin na mas pronounced yung UHI effect dahil mas malaki yung difference ng temperature sa overdeveloped areas kaysa sa vegetation or rural areas. It is because rural areas have higher evapotranspiration rate as compared dito sa rural areas. Since sila ay covered with soil and vegetation, mas madaling nag-evaporate ang heat na na-accumulate within the day kaysa sa heat na na-trap dito sa building surfaces. Next, bakit nga ba mas mainit sa cities? So we have the rural area and then the city, which is paved as compared dito sa rural area which is covered by soil. Cities are hotter because they have paved surfaces na inaabsorb ang energy from the sun. And the vegetation, on the other hand, counteracts the UHI effect through the process of vegetative cooling or the evapotranspiration. Makikita din natin sa urban areas ang construction materials that are very dense and dark colored surfaces like asphalt, which are all good at absorbing and storing the solar radiation. They also evaporate less water na nagko-contribute to elevated surface and air temperature. So ngayon, we often relate urbanization to UHI, and here I'm going to explain kung ano ba nangyayari sa urbanization that leads to higher temperatures. So as cities develop, maraming puno ang pinuputol for developments, for the construction of roads, for the construction of buildings, and as the urbanization rate increase, cars, roads, industries, and thousands of people invade the cities. Also, kapag init na tayo, we often look for air condition, electric fans, or any other appliances that provide cooling. But in very hot days, it can create enormous energy consumption, which in turn results in extra release of the waste heat and air pollutants. And di natin alam na it ends up contributing to an even hotter UHI. So, hindi po natin alam sa araw-araw natin na trabaho, sa araw-araw natin na buhay, nakakontribute na po pala tayo sa UHI or even hotter environment. These are only some of the causes of UHI, which includes low vegetation cover, heat-absorbing surfaces and urban geometry, anthropogenic heat sources, and increase in population. So, our study area is in Quezon City, pero bakit nga ba magandang pag-aralan ang UHI ng Quezon City? One, it is because it is the largest city in the National Capital Region, and imagine it covers more than 1/4 of Metro Manila's land area. Next, it is the most populous city in the country with more than 2.9 million population. And na-mention po natin kanina na isa ang increase in population sa causes of UHI. And next, it is a highly urbanized city that has the most diverse land use among the other cities in Metro Manila. As compared to other cities, mas maraming green spaces ang Quezon City. And makikita po natin yan sa ating succeeding slides. These are the maps derived from Planetscope. This map is called the Soil Adjusted Vegetation Index, which is like the NDVI na pinapakita niya lang kung yung condition ng vegetation sa isang area. And then this map on your right shows the condition of the built-up areas in the city or the distribution of the built-up areas and the vegetation in Quezon City. It shows the spatial variability of vegetation and built-up at a higher resolution because we use Planetscope. Makikita natin na built-up areas are densely built all over the city. Unlike dito sa vegetation na kakaunting spots lang ang may higher value, which is I think in UP Diliman and La Mesa watershed. So let me show you the evidences of UHI in Quezon City. But first, here is an LST map of Metro Manila and surrounding provinces. And obviously, the hotspots are very evident inside Metro Manila as compared to the surrounding provinces which have lower surface temperature in Bulacan, Rizal, Cavite, and Laguna. So here are the surface temperature maps that shows the evidences of UHI in Quezon City. Here's a high resolution LST map of the city wherein cold spots are represented by blue regions and hotspots by the red regions. The maximum value of LST was 36.11 degrees Celsius and the coolest temperature is at 20.93 degrees Celsius. So, let's zoom in sa ibang hotspots ng Quezon City and makita natin na spread all throughout the city ang ating mga hotspots. But kung titingnan natin yung ilan dito, silang lahat ay densely built up areas, and paved surfaces, at lahat sila ay developed areas. On the other hand, when we zoom in the Quezon City cold spots that are these blue regions, one thing common is that they are all vegetated or covered by trees. The northern portion of the city is mostly residential, while the southern part of the city is composed of commercial centers and business districts. So, here's an LST map around the elliptical road wherein makikita natin yung difference in temperature of vegetated and developed areas. The vegetated areas in UP campus, Circle, and the parks and wildlife are the cold spots, while the residential areas and villages around these areas are the hotspots. So let me show you the results of this study, which is an urban land cover LST study in Metro Manila. These are fractional cover maps wherein the vegetation map represents all the plants with chlorophyll impervious surfaces. In this map, which includes mainly pavements, mga bubong, or any material na hindi nag-aalaw mag-pass through yung water. So, ito yung ating mga paved surfaces. Also, we have the soil fractional cover map that shows the both soil and both soil cover and dry vegetation, which are very high in the surrounding provinces of Metro Manila, since hindi sila masyadong developed as compared to the Metro Manila na mataas yung values of mean impervious and opposite of vegetation na mababa. So here's a tally of the mean values of vegetation, impervious soil, and LST. And Quezon City, having more green spaces as compared to other cities, ay nag-rank third in having high mean vegetation. And it is evident kasi nga po maraming green spaces or green parks in Quezon City kaysa sa ibang cities in Metro Manila. However, in impervious soil and LST, hindi po sila nagkakalayo. So, here's a land surface temperature map versus vegetation and impervious map per barangay of Quezon City. And we can see in the maps that there is such strong negative correlation between the vegetation and the impervious surfaces. Since sa mga barangay na mababa ang vegetation or walang vegetation, mataas ang impervious surfaces and vice versa. Thus, when we look in the LST values, low mean vegetation values and high mean impervious values leads to high mean LST. And these are some of the barangays na mainit, which includes the Camias area and the barangay near San Isidro Labrador, which is the road going to España from Quezon Avenue. So let's move to the air temperature maps. These are the maps showing the results of the mobile sensors survey from the Quezon City Hall dito po. And then traversing Quezon Avenue, North EDSA, Roosevelt, and E. Rodriguez back to the City Hall. And this is the morning run, 8:40 to 10 a.m. and 1 p.m. to 2:23 p.m. And makita po natin yung difference between the values in the morning and afternoon run. Since in Quezon City, hottest hour is usually at 1 p.m. Kita natin na maximum temperature was recorded in the afternoon. And itong mga dinaanan po natin ay mga highly urbanized barangays of Quezon City. Also, nagkaroon din po tayo ng survey using mobile sensors from Batasan area going down to along Commonwealth, UP area, and then Quezon Avenue hanggang sa mga residential and commercial areas pababa. And we found out that the air temperature was highest at Batasan Road. And ano nga ba yung meron dito sa Batasan Road na dinaanan namin? The establishments along the road are the area is highly urbanized, and some streets are narrow, especially in some of the residential areas sa Batasan. And lowest values of 32.8 as compared dito po na 37.8 in UP area. Also, we measured the particulate matter or the PM 2.5, which is highest along Commonwealth Avenue and Quezon Avenue, which are both busy roads in Quezon City. These spikes po, this graph shows the PM concentration along the route, and these spikes po ay nangyari along the roads kung kailan tumitigil yung sasakyan. So, high particulate matter concentration is attributed to the traffic. So also we had a field work in UP Diliman, and this map show the standard deviation in UP Diliman area. Para malaman natin kung gaano ba nagbabago yung temperature within the day. We had 3 runs for the same routes, and this is the standard deviation map nung 3 runs na yon. And as you can see here, along the academic oval and then academic oval dito po, ay pinakamababang standard deviation, and it can be attributed to the abundance of trees and vegetation, while the temperature dun sa mga residential areas dito and its vicinities have high standard deviation. So we found out that temperature in areas which have abundant trees, mas maraming vegetation, or mas maraming tree cover, ay hindi masyado nagbabago within the day. Unlike sa mga urbanized area na mabilis magbago at tumaas yung temperature within the day. So, again, here are the factors affecting UHI, which was discussed a while ago. So, another study which is the GIS-based mapping of local climate zones using fuzzy logic and cellular automata. Since ang common problem sa UHI ay pag-distinguish ng urban, alin nga ba yung urban, alin nga ba yung rural areas? And using the administrative boundaries po, may introduce inaccuracies dahil hindi naman po natatapos sa boundaries ng barangays or ng cities yung presence ng urban elements. So, we have this local climate zone scheme that classifies urban and rural areas according to localized climate conditions. And makita natin dito na yung classification ay based sa kung gaano sila ka-compact, kung gaano ba yung spaces between the buildings, kung gaano kataas ang buildings, and the vegetation cover around the area. So here is the result LCZ Map of Quezon City, and we identified 7 out of 10 built-up LCCs and 6 out of 7 land cover LCCs, wherein yung pinakamalaking classification in Quezon City is LCZ 6, which is the open low rise, covering 42% of the land area, followed by the compact low rise, which covers 29%, and the dense trees, which is the largest land cover type, which is 13.38%. So to validate, the map LCCs were confirmed to match the features in the cities. So for example, meron tayo sa Eastwood, which is LCC 1, wherein compact high-rise. Meron tayo nakitang area within Eastwood na maliliit yung spaces between high-rise buildings. Also, LCC 2, compact mid-rise, wherein maliliit yung spaces sa mid-rise buildings. And then, I think we are familiar with Cruz Naligas, which is classified as compact low-rise. These are low-rise buildings na maliliit yung spaces or maliliit yung streets between the houses. Also, we have LCC 5, 6, 8, and 9. 9 was in UP Diliman, sparsely built wherein malalaki yung spaces between buildings at merong mga vegetation and trees. Also, for the land cover types, we have dense trees in La Mesa watershed and LCCG water in La Mesa Dam. Also, some notable areas are the Quezon Memorial Circle, UP Diliman, and we also have the bush in Bagong Silangan as well as low plants. So, para makita natin ang LST sa each LCC type, highest daytime LST was in compact low-rise and densely built houses, and lowest daytime ay sa vegetated areas or the dense trees. Also, for the LST at night, the highest nighttime was in high-rise to mid-rise types, and it is explained by the urban geometry in that area, wherein yung high-rise to mid-rise types ay nagtatrap ng heat in between sa kanila. So, mas mabagal silang lumamig sa gabi dahil mas maliit yung space para mag-release ng heat yung ating mga buildings. And then lowest nighttime ay ang dense trees since mas mabilis yung evapotranspiration rate nila kaysa sa built-up areas. So, here's the graph showing the LST of each LCZ type. Compact low rise, which is 3, is hottest at day, and excluding water high rise type is the hottest at night. And it is explained by the urban geometry present in the area. Also, land types are generally cooler than built types. So to summarize, warmer places mostly consist of impervious surfaces, while those with vegetation cover are associated with lower temperature. And unfortunately, a significantly low percentage of vegetation is present in the whole Metro Manila. The results of the studies presented highlighted the importance of vegetation and green spaces in an urban setting. So now we know the thermal condition of Quezon City. So in the succeeding slides or presentation, we will present to you the mitigation and recommendation of Project GUHeat in mitigating UHI. And that's the end of my presentation. Thank you.